Okay, this is the first of a series of videos that's going to help us to start looking at some review problems for our upcoming air test. So this video kind of goes along with a lot of the stuff we've done in the transformation section of our course. So these are kind of some of the practice problems I found on the state's website that kind of have to do with those kind of problems. So question 1 said circle J is located in the first quadrant with center AB. So if we draw a coordinate plane, somewhere in the first quadrant, which is here, I have a center AB. And around that center we have a circle. So let's say the circle looks something like this. And that has a radius R. Radius from this center to the edge is R units. So it says what we're going to do is we want to prove that this circle is similar. Remember, similar means same shape, different size, to any circle centered at the origin with a radius t. So we have another circle at the origin. Pardon me, this problem says radius s, so this should be s, not r. Sorry about that. So we have another circle at the origin, and it can be bigger or smaller. We don't really, I'll draw it smaller. And this has a radius of t. So it says, what do we have to do to basically prove that these are similar? So what I'll have to do is I'll have to move them on top of each other, and I'll have to basically shrink or make it bigger to see what they would be. Well, to move it, to make them on top of each other, I would simply move them so their centers were the same. So if I'm moving this circle, I'd move it left to the axis, so that would be going this way, so many units, and down so many units. Well, since we know this distance is A because the center is A and this distance is B, to translate it, the rule we would use is we would take the x's and we'd subtract A because we're moving left A, and we'd take the y's and we'd subtract B. So right away, I can eliminate these two because I know my rule to get the centers the same is minus A minus B. So now I got to figure out what the scale factor is. Now the scale factor, if we want to take this one that has radius s, and we want it to have radius t by multiplying it by some number. In class we called the scale factor k. So if I want to take s, and I want to multiply it by some scale factor k, and I want to get radius t. So if I want to know what that k is, I can simply just divide both sides by s, so the scale factor would be t over s. So in this case, C would be my proper answer. That would move the circle to the center, and then it would shrink it down or expand it. I just picked S bigger than T arbitrarily. Either way, it would make it at the center. Okay, so let's look at another one. This says quadrilateral BCDE is shown on the coordinate grid. Keisha reflects the figure across the line y equals x to create B prime, C prime, D prime, E prime. Use the connect tool to draw the quadrilateral. Now this tool on the state test, you can add points by clicking this, and then you can connect those lines with this thing. It's pretty self-explanatory when you get there. So the line y equals x, recall, is the one that goes diagonal. The three lines of reflection we did were x-axis, y-axis, and y equals x. And then, of course, we did the origin as a point. Now, we said the rule for reflecting across the line y equals x is we took all points x, y, and we turned them to points y, x. So we switched the x and y. So if we look at what D is, D looks to be the point 9, negative 10. Or maybe that's 10, negative 10. So that's 10, negative 10. Or positive 10, negative 10. So if I flip it to D prime would be negative 10, 10. So negative 10, 10 would be way up here. So that'd be my D prime. Because D, being 10, negative 10, then that says D prime would just be the reverse of that, so negative 10, 10. If I look at point C, C looks to be 9, -4. And I'm just looking on the coordinate plane. So if I change that to C prime, that would be -4, 9. So if I go -4 up 9, that would put me right here. Right here. So there's C prime. And so you do the same thing. The hardest part for me on this is it's kind of hard for me to read the grid on this. Maybe we can make it a little bigger. So B looks to be 3 and -3. Okay. So B is 3 and -3. Then when reflecting it over the line y equals x, it would be -3, 3, just switching the two. So if I go to -3, 3, that would be this point here. So there would be my B prime. And E would looks to be at 2, -5. So same thing. So if I'm turning E, which is 2, -5, into E prime, it would just be -5, 2. So we're just flipping all these around. And so -5, 2 for E prime would be right about here. And so now if I connect my points, I get this thing that looks like this. So I would believe that this shape here, this original quadrilateral, and this one are flipped over that dash center line. It is reflected over the line y equals x. Okay, this is number 10 from this state test practice. So if you look at this, it says parallelogram ABCD is shown. Point E is the midpoint of AB, and F is the midpoint of CD. And I want to know which transformation carries the parallelogram onto itself. So which of these will basically, if I did it, it would end up looking just like this one. So the first one says a reflection across the line segment AC. So if I flip this across this one, would it be the same? And it would not, because this one, if I flipped it, it would look something like this. Because if I want to reflect this side, it would look like that. So that would not be the same. So right away, I can eliminate that choice. Because that doesn't give us the same shape. Because the parallelogram gives equal parts, but they're turned. They're not actually just flipped. That would be a kite that just flips over this line. Reflection across the line EF. Well, here's EF, so if I draw EF, if I flip this over EF, it would definitely not be the same, because you would see BC would look something like this if I flipped it over that line, which is not the same. So it can't be that one. So we're kind of eliminating. I'm just using logic to kind of eliminate some of these choices. C says rotate 180 degrees clockwise around the origin. Well, if I go around the origin, I'm way over here, so I'm putting this in a different quadrant, so that's definitely not it. So the only choice has to be D, so I know this is the answer, but let's talk about why it's the answer. A rotation of 180 degrees clockwise, which is what we just said, but instead of going around the origin, it's going around the center of the parallelogram. So the center of the parallel right here. So if I turn this 180 degrees, so if I turn this shape 180 degrees, it would end up right back on itself. So that's why that one is the solution for that. Alright, so let's look at this one. Square ABCD is transformed to create image A prime, B prime, C prime, and D prime. And so select all of the transformations that could have been performed. So this is notorious for some of these error tests where they will give you multiple answers to a problem. So this is my original shape. I'm going to put a big O for original. So I want to see what gets to the O to the finished transform thing F. So the first thing says, what happens if I reflect it across the line y equals x, which is this line, right? Well, if I flip this shape, over the line y equals x, it would look just like it does now. It would be right in the same place. So this one is not true. A reflection across the line y equals negative 2x. Okay, well, y equal negative 2x would be a line that starts at the middle and has a slope of negative 2, so down 2 and over 1. So something like this. So if I flipped it over there, would it be the same? Does not look like this would be the same. This would be somewhere, because it's not an identity line. The slope of this is actually 1, so if I were to reflect it over, say, y equals negative x, but not y equals negative 2x. A rotation of 180 degrees clockwise around the origin. So if I took this and I rotated it 180 degrees around the origin, would it end up in that place? And of course it would. So this would be 1. So that's one of our selections, but there could be multiple answers. But that's the first one, so that's good. Obviously, you just rotated 180 degrees, half a circle around, and that was pretty obvious why that one is true. A reflection across the x-axis, and then a reflection across the y-axis. So if I took my original and flipped it across the x-axis, well, that's going to place it somewhere down in this region. So I'll call it x-axis because it was flipped over the x-axis. We flipped it this direction. Well, now if I take that shape and I flip it over the y-axis, it would end up right on F. So this is another one that is actually true. So those are both true in this case. And almost always, I can't say always, but almost always, when they give you these, when there are multiple answers, typically 2 or more are going to work. So at least 2. All right, a rotation of 270 degrees counterclockwise around the origin, and then a reflection across the x-axis. So if I go 270 degrees, 180 would take me to where F is in either direction, but then I'm going to go another 270, so that would put the thing right here, because I'm going 180 and then another 90. That would put it right here. Counterclockwise, so I went that direction. And then it says reflect across the x-axis. Well, if I reflected this across the x-axis, it would actually end up right back where it started. So it doesn't end on the finish, it ends back on the beginning. So this is a no-go. All right, 19 says, Kyle performs a transformation on a triangle. The resulting triangle is similar but not congruent. So similar, remember, means same shape but a different size. Congruent means the same shape and the same size. So what's going to happen if I take a triangle and I do one of these transformations? What will make it a different size? It's not a translation because that just moves left, right, up, and down. Rotation just turns this thing around and around. That's not going to change its size. A reflection just flips it. It's not that one. The only thing that actually changes size is a dilation. Talked about changing shapes by a dilation. Changes the scale of the thing, makes it bigger or smaller. So that's a relatively easy one. Okay, so let's look at this one. Triangle ABC has vertices 1, 1, 2.53, and 0, negative 3. It is dilated by a scale factor of half, becomes half as big, about the origin to create triangle A prime, B prime, C prime. What is the length in units of side B prime, C prime? Okay. So I'm going to draw, since it's got coordinates, I'm going to try to draw a little picture. And, you'll have scrap paper, so you can certainly do this. So there's A. B is 2.5 and 3. So there's B. And 0, -3 is down here. So there is C. So here's my triangle. So it says and we're going to shrink this by half. We're going to make it half as big. And it says, what's the length in units of side B prime, C prime? Well, all we have to do is we have to find how long, what is the length of BC, and then we can just cut it in half. Now we have 2 points, which would be 2.5 and 3, and we have C is 0 and -3. Well, we have a distance formula that will tell us this. If you remember the distance formula, it is x1 minus x2 squared plus y1 minus y2 squared. And if you've forgotten that, good news, it is on your formula sheet for the test, so it will be one of those you have on there. As will your trig functions, as will Pythagorean theorem, as will your 30, 60, 90 triangles, as will your volume and area formula. So I make sure I look at that sheet, which is attached to this, where you can kind of see what you're given. So BC, if I take the difference as an x, 2.5 minus 0 squared plus 3 minus -3 squared. So BC is going to equal the square root of 2.5 squared. 3 minus a -3 is going to become +3, so it's going to be plus 6 squared. So I just put this in the calculator. I get the square root of 42.25, which I figure out what that is. That gives me 6.5. So BC is 6.5. So B prime C prime, which has to be half of that, would just be half of 6.5, which would be 3.25. So I just got that with 6.5 divided by 2. Okay, a translation, so a movement is applied to triangle PQR to get triangle P prime, Q prime, R prime. So we're taking this guy and we're moving him to get this guy. Let the statement X and Y going to points A and B. So I want to create equations for A in terms of X and for B in terms of Y that could be used to describe the translation. Okay? So we have this point Q. Let's say Q here. So Q appears to be 3, 1. And so we move Q to Q prime. Q prime is going to, so this could be, say, my X and Y. And then my A and B where I'm going. So that Q prime is at -1 and 4. So you can see the x value from 3 to -1 has gone down 4. And 1, which was the y value, has gone up 3. Okay. So these new AB values were just the original x values minus 4. And the B values, which are our new points, so how I got the new point 4, pardon me, is I took the old y value and I added 3. So this is just a real simple way to make kind of a real weird abstract problem. Just picking a point, I just see how it moved. It went left 4 and up 3, so I just use those in my rule.